Hey everybody. So we are looking at 9.4 divide polynomials. All right. Before we get into this though, I'm going to have you guys kind of recall what we were doing on the previous section in 9.3 where we were multiplying polynomials. On this one specifically, two binomials. All right. So go ahead, copy this one here, give it a try, and then we'll get into the new stuff. Okay, so you guys remember when you went to multiply, the idea is that, both of these terms here need to be distributed into this other parentheses. We'll just start with the first one, 2x. All right, so I always like to show the arrows. You don't necessarily have to, but yeah, 2x times negative 5x gives me a negative 10x squared. Be careful on this. 2x times 2y, well, that's going to give me a positive 4. X times y is just xy, right? Moving on to the next one, negative 3y being distributed. Okay, negative 3y times negative 5x. Well, looks like we're getting a positive 15 and then xy. Okay, remember, whenever we multiply variables, if they're different, we put them alphabetically, right? So not yx, xy. All right, and then moving on, negative 3y times positive 2y. Well, that gives me a negative 6y squared. All right, and normally on these type of problems, after we multiply, we'll usually end up with some like terms in the center, and that's exactly what's happening here, right? We have some xy's that we can combine. So, negative 10x squared, there are no other x squared, so we'll just bring that down. If you want to cross it out, go for it. Okay, so a 4 plus 15 is going to give me a 19xy. Again, you can cross them out. And then we can see we just have this negative 6y squared to bring down because there's no other y squareds to combine it with. Right? And there it is, nice and clean. Okay, so yeah, that was the multiplication. Today, we're getting into dividing polynomials. All right, the good thing about this lesson is it's going to use a lot of skills that we used in the past when we were, canceling out variables and reducing fractions. Really, there's not a whole lot here. It's just in the context of polynomials now. Okay, so yeah, go ahead, get the title at the top of your paper, get this first example, and we'll try it out. Okay, so this one is representing this as, I guess, a sentence. We want to turn this into an actual problem we can make some sense out of. So let's write this as division. So it's saying divide negative 8x to the power of 5. So we have negative 8x to the power of 5, and they're saying they want us to divide it by 2x squared. Okay, so that's being divided by 2x squared. All right, so this is really how we're going to represent this. Okay, from here, again, we're doing the stuff we've learned in the past. Okay, so first thing I notice, I have a negative 8 divided by 2. I can actually divide that evenly, right? I could reduce it, but I can also divide it. It's the same difference. So this is going to turn into a negative 4 up in the numerator. All right. Now I need to worry about my variables. You guys remember, variables, when we're dividing, we're basically thinking of it as canceling. If I have 5 x's up on the top and I have 2 x's down on the bottom, okay, remember, we can cancel them out. Every x on the top cancels one on the bottom. And what we're left with after we can't cancel anymore is, our answer. So we have 3 x's left up in the numerator, which would be left as an x cubed. Okay, the denominator is completely gone on this problem. Technically we could write it as over 1 because, nothing's there, but it's unnecessary. We'll just leave it as this. Okay, but just know sometimes you will have things left in the denominator. So, don't always think, oh, we just get a nice clean answer. Not always the case. Sometimes we're left with a fraction. Okay, so let's try another one here. Again, dividing monomials, probably don't need that. Go ahead and just copy this and we'll try this together. Okay, so on this problem, negative 4 over negative 16, this does not divide evenly, but I can reduce this. Maybe the first thing to realize, double negative is going to turn into a positive. Okay, so that's the first thing I'm realizing. I have a positive, whatever I happen to get, it's positive. Okay, 4 over 16, I can reduce, right? A 4 goes into 4 once, and a 4 goes into 16 4 times. Okay. When it comes to my variables, I have 3 x's on the top and 8 on the bottom. Again, if it helps to write it out, you can, but you don't have to, but I really want to just kind of remind you guys, if I have 3 on the top and 8 on the bottom and I cancel out, and again, I would like you to actually just do this in your head. It looks like we're left with 5 x's down in the denominator. All right. So down here, we have 5 x's or x to the power of 5. Yeah, and there it is. Okay, so obviously there's an example of a problem that, we're left with a fraction. We have stuff left over in the denominator. Everything in the numerator got, either reduced or canceled, but we need to show that there's a 1 up there. Okay, so I'm going to have you guys go ahead and try a couple of these on your own, and then we'll move on to just a couple more. All right, so on number 1 here, negative 3x to the power of 7 divided by negative 9x to the power of 4. So this is where we would want to, turn this into a ratio. Okay, so this negative 3x to the power of 7 goes on top. It's being divided by the negative 9x to the power of 4. Okay, so that's the first maybe important step. Now we can go ahead and notice, okay, my numbers, I can't divide a 9 into a 3. That's fine. I can reduce a 3 over 9. By the way, double negatives turning into a positive, right? So positive, 3 goes into 3 once, 3 goes into 9 3 times. Okay, variable-wise, 7x's on top, 4x's on the bottom. If I cancel them out, just think of it in your head, I'm left with 3x's up in the numerator, okay, or x to the power of 3. Okay, and really that right there is my answer. I would probably go one more step and write it like this, just x cubed over 3. Get rid of that 1. This looks a little nicer, so I'm going to write my answer there. Okay, taking a look at number 2, I have 8x divided by negative 6x to the power of 5. First thing with my numbers, they do not divide evenly, but they do reduce, right? 2 goes into both of these, right? 2 goes into 8 4 times, and negative 6, negative 3 times, or I guess, that negative is staying here. Okay, x's, 1 on the top, 5 on the bottom, cancel them out. I'm left with 4 of them down in the denominator. Okay, so there it is. And this is our answer. I just want to point out, whenever there's usually a negative left over and there's, a fraction, usually it'll go in front. So I'm actually going to write this. I'm going to rewrite it. I'm going to put the negative in front and write it like this, 4 over 3x to the power of 4. These are the same thing. This is just a little arrow saying, these are equivalent. But I think this looks better. Okay, so yeah, that's dividing monomials. Remember that was, I guess should have pointed that out, but a monomial was a polynomial with just a single term. All right, so we were just dividing monomials on this. Let's look at a problem where we're dividing a polynomial by a monomial. Okay, go ahead and copy this. Okay, more specifically, this is a trinomial being divided by a monomial. Okay, so here is really all that's happening. Every single term in the parentheses here needs to be divided by a 2x squared. You can think of this almost as distribution. I mean, really, it is distribution. And if it helps you to draw the arrows to kind of remind yourself in your notes, it's not a terrible idea. But I'm going to basically rewrite this. So I'm going to say, okay, I have a 4x cubed, which is being divided by a 2x squared. I have a positive 8x squared being divided by a 2x squared. And I have a positive 10x being divided by a 2x squared. Okay, so that's the first step on this problem, is basically writing these into a bunch of fractions, a bunch of ratios. Okay, and now it's just like the other problems. We're just doing, 3 of them instead of just 1. All right, but we can probably do a lot of this in our head. So 4 divided by 2, that divides, so I'm getting a 2 up top. 3x's on the top, 2 on the bottom, cancel out, I'm left with 1x up on the top. Okay, so this one I'm left with just a 2x. Nothing's left in the denominator. I could write it over 1. I'm not going to. Okay, moving on to this one. First of all, there's a plus sign. 8 divided by 2 is a 4 up top. 2x's on the top, 2x's on the bottom. All, 2x's all canceled. There's no more x's left. So on this one, I'm left with just 4. Okay, moving on. 10 divided by 2, again, that divides. I'm getting a 5 up in the numerator. Okay, the reason why I'm kind of putting it up here is I noticed with my x's, 1x on the top, 2 on the bottom. When I cancel, I'm going to be left with 1x down in the denominator. So I'm going to write this as 5 over x. All right, and there it is. By the way, if you were to write these as, over 1, you could do that, but I would probably have you go another step and get rid of those ones and write it like this. Okay, and I'm just looking to see if we have any like terms. We don't, so there's nothing else we can do here. One other thing you might, if this was like a multiple choice problem, it might not be written in this order. I'm guessing if they were to rewrite this, they would write it as 2x plus 5 over x plus 4. They would put this constant at the end, okay, and then maybe put this 5 over x here. These are kind of interchangeable, but just know that this could happen, but I'm okay if you just leave it like this. Okay, so last thing, I'm going to have you guys go ahead and try one of these on your own. Okay, so yeah, all three of these terms is being divided by a 3x cubed. So let's go ahead and write it out. 6x cubed is being divided by a 3x cubed, plus 3x squared is being divided by a 3x cubed. And then don't forget there's a minus 12x is being divided by a 3x cubed. Okay, and let's just kind of simplify these one at a time. So 6 divided by 3 does reduce, so I'm getting a 2 up in the numerator. 3x is up top, 2 on the bottom, cancel out, I'm left with 1x up in the numerator. So that just turns into a nice clean 2x. Okay, 3 over 3, those basically cancel out. They do reduce to a 1, but we'll see if the 1 is actually necessary. We'll just think of those as kind of canceling for now. We have 2x's on top and 3x's on the bottom. That means when we cancel, we're left with an x down on the bottom. All right, that means up top, everything was either reduced or canceled, but we need to show that, there's a 1 left over in the numerator. Okay, so turn into a 1 over x. And then last thing, 12 divided by 3 gives me a 4 up top, 1x on the top, 3x's on the bottom, cancel out, I'm left with 2x's on the bottom. Okay, and there it is. There's our answer. This order, I'm fine with this. Maybe this x squared should go in the front, but I'm okay with what it is. Just realizing there are no like terms here, so we're done. Okay, cool. So yeah, that is dividing polynomials, really just using a lot of skills we learned in the past. Nothing too crazy. So yeah, I'll see you guys.